From
All
Tunisia.
right.
Nice.
Tunisia. That's awesome. Romania.
Romania.
Holy cow. That's quite the crowd we have here.
Exactly.
Well, Mr. Bruno, let's get started here. Thank you, folks, for joining us from almost literally across the world. We're excited to have you here. Excited to be doing our first Shipa workshop. This first topic that we have chosen is how Shipa works with GitOps. Just for the sake of good order, we are recording this, and so we will send you a link to the recording after we are wrapping up here. So Bruno, do you want to just flip to the agenda slide, and I can walk that through, and then we can get started. So let's just get everybody on the same page and talk about what is GitOps, what is it, how is it defined, what are people using it for, as people are starting to use it, challenges become apparent, and then Bruno will sort of start diving into the details about how we're gonna work together, Shipa and GitOps, what's the architecture, how are we defining frameworks in Shipa and allowing them to be used in your GitOps tool, and then going sort of into some very hands-on tasks. So with that, I'm going to introduce the lead guitarist tonight, Bruno Andrade, and he's going to take it from here.
Yeah, thanks, Henrik. And quick message as well. I think I saw someone saying that you were not able to hear us. Maybe kind of checking the Zoom sound output, because other folks are saying that sound is working fine. But if you have questions, just message us, let us know. Thanks, Henrik, for the intro. As you can see, guitar is my thing, and music. My original plan was actually to be a musician, but I realized that I was not good enough to make a living out of it. So I decided to change to software engineering. Later, I also realized I was not good enough to make a cut, but then it was too late. So now I have just to stuck to it and see where it goes. And thanks everyone for joining. The idea today is to kind of go hands-on across the how to set up kind of a workflow around GitOps with a policy, security, and defining an application model that can be deployed across multiple clusters, and if we have time, even across Linux nodes. But before we go into that, just to set some expectations and kind of bring everyone to the same page, let's talk a little bit about the GitOps definition, right? I think one of the definitions that we've seen being used and that we really like is that GitOps is an operational framework that takes the DevOps best practices and allows you to apply that to infrastructure and application automation. And that's great, but I think the phrase that we want to focus on today is an operational framework, right? An operational framework means that, and we believe that it should actually be able to apply that operational framework across not only your infrastructure automation, but across your application deployment, and not only deployment, but security, and not only on Kubernetes, but also across different infrastructures such as Linux VMs, either on-premises VMs or Linux VMs. And we'll talk about it shortly. Before we start, it would be great to get some of the state where you guys are in terms of, are you currently using GitOps? We have a poll. It should be showing up on your desktop. If you can click on it, that would be great, so we understand where everyone is, and we'll share that information later with everyone, so it becomes really valuable for all of us. We can see that a lot of folks are actually not yet using, but are considering using it, which is pretty great, and still a good chunk of it already saying yes, implemented and in production. That's great. Some numbers are still coming, and that's great because we hear a lot about GitOps, but we see, and that's the reality we see out there as well, that a lot of people are just kind of in the initial phases or exploring it. Okay, so that's great. Thank you very much for that, folks. We'll have other pools as well, so we would love to see you participating. The second question that we have as well, let me share the results with you. So this is the results that we have. Most of the folks that voted, they are currently considering GitOps, but are not yet using it. So that's great. And 20% of the folks who voted, they are already even in production with it. That's awesome. And I would love to hear your thoughts, both of your thoughts, who is at the stage of implementing, exploring, and who is in production already on the approach we take here. The second question that we have is, when you're using GitOps, especially for the folks that, well, for everyone, what tools are you currently exploring? Is it ArgoCD or Flux? There are pros and cons across both tools, and they're different and they have their strengths and weaknesses, but it'd be great to get your thoughts on that as well. There's a massive number of folks going to ArgoCD. Maybe later we should start a discussion on why you folks are going so much for ArgoCD. Hey, Kenneth, there should be two choices on your screen, ArgoCD and Flux. Oh, the UI. Yeah, I hear that quite a bit, actually. Oh, you use both, actually. Ah, I see. Thanks, Kenneth. I'll make sure that in the next session, this is actually for both an ecosystem. Yeah, makes sense, Andre. I'll add that as a third option. And ArgoCD is easy to use. Yeah, competitive about Argo and Flux will definitely do. And GoCD too. Oh, true. All right, let me share the results with you folks. So you can see that at least today, a lot of the folks, most of the folks voted on ArgoCD, and my mistake, some of you actually said that you're currently using both, and that's awesome. I didn't expect in this stage to see folks using two tools at once, but great. So let's get started in here. And when we talk to folks around some of the challenges that they see, is one that it's tied to Kubernetes, right? When they're adopting GitOps. And the reason why I say that is because you have tons of infrastructure already in place. You have tons of VMs, either on premises or EC2 or Azure, for example. So what do you do with that? And because most of these tools today, they are focused primarily on delivering to Kubernetes, your VMs, you have to use a different pipeline, a different way of defining and delivering the apps. And then you have to define and deliver apps in another way for Kubernetes. And then it's a different way on how you monitor and so on. So not being able to address multiple infrastructure from a single GitOps pipeline adds a lot of complexity, especially for folks that are using it at scale. Some of the companies that we talk to, they are using in the hundreds or thousands of developers, for example, and thousands of services, and that can be a nightmare for them. The second point is the complexity for developers. Even though for DevOps folks, we don't see a problem around running kind of Helm charts and maintaining that. We see quite a few developers actually complaining about the whole experience of having to learn and use these things and maintain and even understand their applications post deployment and how to support it becomes challenging. Monitoring security and more. So a lot of folks focus only on the CD part, right, on the delivery part, but there's much more to it. So when you're delivering your clusters and so on, you want to make sure that your applications, they have monitoring, you have security in place. And security is not just security scan, it's a much broader topic. It's actually around RBAC, network policy, registry controls, and so on. And that can get quite complicated across a large number of clusters and a large number of apps and services that require different security requirements, for example. And last but not least is audit, right? We see folks saying that audit is easy because everything is Git-based. But we talked to a few folks that started using GitOps at some good scale. And what they said is that because this is actually tied to Git, everything that you change actually generates kind of a new history, right? So if you change a parameter, if you change a label, not necessarily a deployment, everything that you change actually creates a history. And when you need to actually go back, for example, to your DevSecOps team or to your security folks in general, and you need to show kind of the deployments that happen across specific applications at large scale, that can become kind of a hard dance to figure out and pull out the Gits and so on and so forth. So what we're going to be doing here today is we have a GitHub repo. I think we sent it on an email a day or two before that you guys can look at. Again, if you want to do it step by step with us, that's great. You're more than welcome to do it, but you are also welcome to sit back and watch it as we go through and ask your questions. We have an ArgoCD. We're going to install an ArgoCD instance. The purpose today is not to teach you how to use Argo exactly and the different kind of setups of Argo, but to show you how it works all together. And on top of that, we have a Crossplane Shipa provider, and we're using that so you can see how Shipa can integrate with Crossplane to do the resource sync. So if anything happens, an application is deleted or something is changed, that causes a drift between your desired state in Git and what is in Kubernetes. So we can sync that back and bring it back to the desired state. These are all going to be calling Shipa Cloud API. So I'm going to be using my Shipa Cloud account. You also probably saw that in the email. You can create an account and you can use a free account under apps.shipa.io. If you have not created one, you still have time to go in and create. And even after this session, it would be great to hear your thoughts if you get a chance to give it a try. And we're going to be deploying these applications to 2 frameworks or 3 maybe during the test. One development framework and one production framework. And these frameworks are going to be hosted on a Kubernetes cluster. We're going to change it a little bit. Maybe I'll do dev, QA, and production so you can see kind of how different frameworks can have different security settings, and they can be bound to either the same cluster or different clusters. And you're going to see how this becomes easy to manage with Argo. The GitHub repo URL, I'll send it in a second. As soon as I kind of flip over my screen, I'll send you folks the GitHub repo. But this is the apps.shipa.cloud, and I'll share the GitHub with you folks soon. So just a quick refresh for some of you that are new to Shipa, what a framework is, just to be clear, is a framework is where DevOps teams, they have a chance to actually define, oops, seems like my PowerPoint is too much technology for me. There you go. But frameworks is where you can actually define your rules and controls around application deployments, network policies, registry controls, and so on and so forth. So it's one common way that you can define it without having to write complicated legal rules and so on and so forth, and extensive legal rules and so on, and have to manage those, so on and so forth. So here are these steps. Oh, there you go. Here's the link it's at shipa-corp /GitOps-workshop GitHub. So you can clone that as well. And we're going to be using apps.shipa.cloud. We're going to be installing Argo in our case cluster, install the Shipa provider for Crossplane, create the 3 frameworks, connect them to our cluster, and deploy the apps. Yeah, of course, Andre. Oh, there you go. Octavian did it for us. Thank you. Appreciate it. And just before we get started, as we get things prepared, what are the challenges, if any, that you are facing with GitOps today? You should see something in your screen. There you go, coming up. Oh, there you go. Thanks, Joseph, for sharing the URL as well. Yeah, security is definitely one challenge, and security is a much broader challenge. I think not only from kind of how do you store secrets and so on, and in using Argo and so on, but defining security overall across network policy, registry controls, and others seems to be challenging for most folks. And yeah, the concept with developers, and that's fair because developers, they are used to deploying applications, and things are changing quite a bit in their microservices. So we see that quite a lot. Yeah, and stateful resources, that's a big one. Let me share the results with you folks that we have. Share results. There you go. So that's what we're getting from the folks here today. Most of it is around complexity for developer adoption, followed by a tie between enforcing security as part of the pipeline, as well as not easy to replicate monitoring ingress. That's a big one as well, because people think it's just create a cluster and that's it, but there's a lot more moving components, right? All right, so let me go to my screen. Thanks for the input. I see some more coming in. The limit of our developers dealing with Docker, nothing further than this. Yeah, I agree. So you should see my screen now. Let me close some of my things here so it doesn't get in the way. So what you're seeing is my Shipa Cloud account dashboard. Again, you can create your account on apps.shipa.cloud. So you can get exactly what I'm seeing here. Here's the GitOps workshop. I cloned it into my account, so I'm going to be using that because if folks from my engineering team, they're here, they're going to be crazy with what I'm going to be doing with the secrets. Again, the purpose is not to teach how to store secrets in Argo, so we'll keep things plain. And whatever I'm showing here is just development environments. So I'll destroy everything right after. And everyone's been dealing with secrets and so on in different ways so far. So yeah, my engineering team, don't kill me. Peace. I've cloned that into my personal repo. I have my documentation that I'm going to refer to, and I have a few Kubernetes clusters, right? So let's see, I have my Shipa Cloud account created, and I have 2 clusters here that I'm going to be using. If you have one, that's fine. I'm going to be using 2 so you can see kind of how we can distribute the frameworks. So the first one is one called GitOps Core, and the second one is GitOps Prod. I'm going to be installing ArgoCD and the Shipa Crossplane provider here, actually, on the GitOps Core one. I have my terminal here. Let me see if there's anything. Okay. Let me just try to make this larger, but if you folks cannot see it, please let me know. So what I've done here, I just configured kubectl, kubectl, kubecontrol, whatever we want to call it. I can reach it. I can get nodes. If I see, I have just the regular namespaces that were created on my cluster. The first step I'm going to be doing is I'm going to be installing Crossplane and the Shipa provider. The part of the documentation that I'm going to be following to do it is this one here. Let me send everyone. It has detailed explanation on how you can get Crossplane and the Shipa provider installed, and we're going to be following exactly that. The first step I'm going to be doing is creating a namespace for Crossplane. And what I'm following here, it's pretty much from their documentation. There's nothing kind of custom that I'm doing at this point. I already have this Helm repo added. I'm just going to do an update just to make sure that I have it on the updated version. And I'm going to do an install. That's right. Thanks for sharing the link, Vivek. Oh no, Vivek is here. So he's gonna kill me later for kind of doing what I'm gonna do with the tokens and certificates. I'm sorry, Vivek, just in advance. So if I say get namespace, I can see Crossplane here and it's active. And if I do get pods, I can see Crossplane is running. Great. Now we can install the Shipa provider, right? You can copy these content here. Yeah, let me share the link again as well, just in case. This one goes directly to the page that I'm following up. We're going to create a file called Crossplane provider Shipa.
Hey, Bruno, you're
Yeah.
just sharing it to the panelists, which would be me and you. Remember to click attendees.
My screen, you mean? Oh,
no, the links. The links.
Oh, too much technology. I'm telling you. There you go. Thank you. Sorry, folks. I'm still learning. That's why I said I noticed I was not good enough on engineering as well. So you can see it. So you can create a file called Crossplane provider Shipa, or you can choose the name. I already have one here. Provider. Let me see, where is mine? Crossplane provider Shipa. It's pretty much the same content that we have there. I'm going to apply this file. Great. It has applied that. The second one is to create the secret. So this is how Crossplane will actually communicate with your Shipa API. The things that you are going to need to add is one, your Shipa Cloud endpoint. I'm going to keep HTTP here because later on we can extend, or we can send you detailed information on how to add HTTPS with your certs and so on. But just for the sake of the development, I'll show you doing an HTTP. And we're going to need our Shipa token as well, API token. How we can get that? We can use Shipa target list. For example, I'll send you the comment here. Now going to everyone. Thanks, Eric. I can see the target that I'm using. You can see the star here. This is my target, target.shipa.cloud, and it will be exactly the same one for you. So if I go into, I'll just copy this target.shipa.cloud. And if I go into my secret file, I'll update this. So yours should look exactly like this. HTTP target.shipa.cloud port 8080. Again, we'll send you more instructions on how to add. Port is 80. Thanks, Igor. Port 8081 is actually when you're using HTTPS. For HTTP calls, it's at 8080. I'll send you more details on how to bind your certs and use 8081 with HTTPS. But for this, just use 8080, please. And the second one is to get your token is Shipa token show after you have added Shipa client to your terminal and configure that. And you can find more details on the Shipa client here. This is where you can download Shipa client, and you're going to see that you have a version for self-hosted and a version for Shipa Cloud. We're using Shipa Cloud. So if you're using Shipa Cloud as well, copy this one, please. After you have Shipa client configured, you can use Shipa token show. Shipa token show is going to show your user token. And I can go in here, update my file. All right, this is done. So with this done, I can apply this file. So I'm back into configuring the provider section. I apply this, this is created. And last but not least is the Shipa config, which I'm creating inside a crossplane-shipa-config YAML file. Again, you can name it whatever name you like. This is just a suggestion. You can copy the content from here. And once copied into the file, you can just apply that file as well. Great. At this point, if I do get pods, I already see my Shipa provider running here. And if I do logs, for example, Crossplane system, I can see the controllers already being deployed and start to monitor. Great. So now next step for us is to actually install Argo in that cluster. You can find some details here in this page, but I'm going to be following Argo's own documentation on how to install it. It's pretty easy. I mean, for a dev environment, which is this page here. I'm going to be following steps 1, 2, and 3, and 4. Everything else is we don't need for this demo here today. So the first part is to create a namespace for Argo. Can this install process become part of the Helm chart? It can actually. We will definitely prepare kind of a Helm chart or a better version of the install that installs the whole package for you. The reason why we haven't done it yet is because most folks, they already have this in place. Yeah, that's a great one, Nikhil. Thank you. The second one, I'm going to be applying the Argo install manifest. So for Sarah, we're not going to be doing port forward. I'm just going to be using service type load balancer and do the patch. So we don't need to do the port forward in this case for us today. All right, it is already installed. The second step here is for you to actually download and install Argo CLI. I already have mine actually, so I don't need it. If you do, you can install it using brew. Then I'll jump into step 3, which is patch the load balancer, which is done. Now I'll skip, as mentioned, I'll skip the port forward for now for the demo for the purpose of this tutorial or workshop. The other one, I'll log into my Argo. To log into Argo, we have to find the admin install password, which we can do with this comment here. And we're going to use this to log into our Argo. To know the address of Argo that we're going to be logging into, we can use kubectl get services, for example. I'll use flag A and I'll grab ArgoCD server. It's coming up, so it takes about a minute. Pending. It's taking time. So let's talk about Netflix. What are you guys watching lately? Oh, there you go. Okay, so now we have the, Now we have the password and the login. So if I do ArgoCD login and I just pass the IP, Ozark, season 4. Thank you. I actually just watched season 1 and 2, I think. Thank you. I missed one number. That's right. The username is admin. And then the password is this password here. Again, not concerned about the password and everything. This will be all deleted after this. And after you log in the first time, you can update your password with ArgoCD account update password. I usually do it just to make things easier later. it's really an option. Great. So if we get this IP that is exposed, we can probably at this point log into our Argo. Again, it's no certificate here. This is a development instance. Okay. Admin and the password that I just set. Yep, sounds good, Andre. You can definitely follow up later. Okay, so now we have Argo installed, we have Shipa and the Crossplane provider installed. So the next step for us is to create the frameworks, right? If we go into Shipa's dashboard, again, frameworks are how we are going to define things such as resource consumption controls, access controls, application quota, registry controls, and so on, without us having to write those complicated and long legal rules or Kubernetes specific. And when I say Kubernetes specific is because you can apply these frameworks to also Linux nodes. If we have time, I'll show that soon. But as an example, you can say here dev framework. You can pick the ingress you want. Provisioner is either Kubernetes or Shipa, which is basically Linux, but we'll keep Kubernetes so you understand it. Resource consumption is how much resources such as memory, CPU, and swap applications deployed through this framework will consume. You can create multiple plans and you can bind these plans to the framework. So every app that you deploy will get these as limits. And just kind of so you can relate better, every framework that you create and you bind to a cluster becomes a namespace in your cluster. So it becomes a namespace with all these policies that you are creating here attached. Access controls, if you have multiple teams, you can select which teams can deploy using this framework. And that's a very good point because when you're using Shipa and your teams are deploying, pointing to the Shipa API, you actually take them out of Kubernetes. So you remove kubectl from your developers. They don't need to use it and learn. So you don't need to manage RBAC there. You have a much easier RBAC option here on Shipa. And you can set the teams and users and the permissions here inside Shipa, not only through the UI, but also I'll show a little bit later how to do that entirely from Argo. But here you can either set the teams that can use this, or you can set the framework as public. So everyone can see this framework and everyone can deploy an application using this framework. Application quota, so you can say how much an application can actually scale. Each individual application can scale. Here you can say registry limits, for example. So if you want to say Docker Hub, if I can write, for example, Shipa software. So only images. So when you deploy an application or applications to this framework, it can only accept images coming from this registry. Anything else just block the deployment entirely. And you can list multiple ones here, or you can just leave it blank. And if you leave it blank, basically it will say that any image from any registry can come in. So if you're using JFrog Artifactory inside or ECR, for example, or GCR for Google, I think, you can actually map these here and say, well, for framework dev, only allow people to pull from GCR. And for production, only allow people to pull from Artifactory. You can do that here. The second one is, so D1 said similar to allow list, right? And deny list. So everything that you, and registry from GitLab, yeah, you can use the registry from GitLab as well. And if you do Docker Hub here, for example, Shipa software, you don't need a deny list because then anything else other than Docker Hub Shipa software will be blocked. So it's not going to be accepted. So this is the only allow list. No worries. The other part is network policy. We see folks are starting to use network policy, and a lot of them, they say it's a complicated matter, especially for developers who have to deal with kind of ingress on Istio and so on, and rules and so on and so forth. So we made it in an easier way where you, as the DevOps role, you can enforce default network policies. So what means is that when applications are deployed by the developers, these policies will be automatically enforced by the framework. So you can set deny all, for example, for both ingress and egress. So when they're deploying apps, everything will be deny all. But you can also allow them to say, allow app level policies. So the owner of these apps, they can later go in and customize app policies for their apps, but by default, they get an initial policy that you define. As mentioned, you can come here and say allow all, deny all, or you can go very specific and say, I don't know, maybe a gateway rule, where you can say applications deployed through this framework can only connect to another framework, for example. So you can set these predefined rules here as well. Yeah, you can set by application specific, in case you want to say, hey, specific application gets allow all, for example. So here, this is just an example, and then egress, you can do the same, and then security scans. So Shipa by default, Shipa does security scans using I forgot the name, Claire, actually, from Red Hat. If you have other GCR and so on doing the scans and you want to disable it, you can. But if not, you can also be part of your Shipa workflow or your Argo workflow in this case, and where you can say, hey, run a security scan at both the application level and the image level. And if you find glibc, for example, just ignore and treat that as an exception to the vulnerability. Or if you find CVE, whatever, treat this as an exception as well. And later on, Shipa will keep on running scans in your image post deployment as well. So if there's any change or anyone tries to introduce something directly post deployment, Shipa will pick it up. That's being really good in terms of an audit history as well for DevSecOps team, or you can disable it altogether. We're not going to be creating this framework from here. We are going to be using Argo, but this is just so you see that you can create it from here and kind of what it looks like. And Shipa does not use OPA framework. Shipa is defining the rules directly on Kubernetes, and you're going to see that these rules can be applied to Linux as well and so on. We wanted to get the user out of the OPA complexity and so on. So you're going to see how this all plays out. And the way we've seen folks using frameworks is basically to separate environments such as dev, QA, and production, or to separate projects, maybe a framework for project 1 where all the services are going to be there, project 2, or different teams with different security requirements. So you can customize and create as many frameworks as you want and bind as many frameworks as you want to a single cluster. After the framework is created, the second step is to bind a cluster. So let's see how we can do that from Argo. As part of my GitHub repo, I have a folder here called frameworks. If I see frameworks, my framework file, let me just make this a bit bigger. My framework file, I have 3 frameworks here, one called dev, another one called QA, and another one called production. Here, just for the sake of simplicity in the demo, they all kind of have the same definition, but you can see detailed definition here. Let me send you this link where you can customize registry control, security scan, everything that we saw in the dashboard. You can also see that from here. Okay, so if I come in here, I already have cloned this and I have frameworks. I have my Crossplane Shipa YAML file here. So it's basically everything that is in my GitHub repo. So I'm gonna point Argo to my repo. I'll connect it there. I'll connect Argo to this repo now. GitOps sample. I'll do cat. Again, there are different ways you can connect your GitHub repos to Argo. All right, connect. Done. So I'm going to create an application called frameworks, right, in Argo. I'll keep the default process and I'll do automatic for the sync policy. And the source is going to be the GitHub repo that I just added. And the path is going to be this one here. Path, there you go. And the cluster is going to be in cluster. Because Argo is going to be pointing to the Shipa API, you don't need to actually set up every single individual cluster that you have. Argo will just call the Shipa API. Shipa will enforce all the rules and deploy the apps. So you can click on create. Okay, if we create, it's going to be out of sync. Yeah, that's true, Sarah. Thanks for mentioning that. That is right. If we go back to our Shipa instance, I can see the frameworks here, for example, dev, prod, and QA. And you can see the definition here. You're defining security across registry control, network policy, and everything that we just in a much easier way. And you can see that the same security configuration or definition can be applied later to Linux nodes. Some folks even started calling the approach we're taking as security as code or something around that. So you can apply this security moving forward. But great, we created these three here. The next step is for us to connect a cluster to these frameworks, right? I have my GitOps core, which I'm going to be connecting here. To connect a cluster to Shipa, you can follow the instructions here to find the details that you need. The first one, and if I go here in my cluster definition file, I see that I have the connection to 2 clusters, and it asks, the basic connection is, it asks me for the cluster address, which I can find by using this. I'll just put it here. Again, no worries, I'll delete this all later, so I'm not really concerned about the details. This, I'm not going to play around with storing secrets and so on and so forth. The second one is I need to create a service account for Shipa in that cluster so Shipa can connect to it. Oops, sorry, wrong. I already have this file here locally, so I'm just creating this. I'll need a token in that file. To get my token, I can run, and I'm going to run a little bit because I want to be respectful of your time, but again, the recording will be made available later. You can get the token directly from here. And if I go into my file, I can update my token here. And last is my get my certificate. Here. Okay. I have to do this. Otherwise it will complain. Thanks, Yamo. So the first step was for us to actually create the frameworks or the policies that we want to be applied. We created 3, dev, QA, and production. I think for the sake of simplicity and time, I'm going to do 1 cluster only, binding all the 3 frameworks. But you can bind it, as you see here, you can bind multiple different frameworks with different clusters. All right. Great. So, and here in the last, I'm binding the frameworks that I want, right? Or the frameworks that we just created. So I'll do dev QA, and just to keep things simple and fast, I'll do dev QA and prod. If you have multiple clusters, you can say maybe dev and QA on the first cluster, prod on a second cluster. So you can bind multiple frameworks to different clusters. I'll delete this here. Okay, so I have my cluster definition here. What I'm going to do is I'm going to add this to Git. Great, so this should be in my Git repo here. Clusters. Okay, I see that it was just updated. I'll go to Argo and say, now I want to create a second application called clusters. So I can manage centrally all the clusters that I have. You can structure it differently if you want. Also, I'll do automatic as well. Same repo URL. If I can click. And then path, okay, cluster, okay. And create. Okay, it sends the request to Shipa, and Shipa will start adding the cluster here. So you can see that the process actually starts to adding the cluster. It's running in a second. Shipa will finalize adding the cluster and combining the three frameworks and hence creating the three namespaces in your cluster. You can see, and when you go to the cluster page, you can see our cluster name here, Argo Demo 1, and you can see the three frameworks bound to that cluster. Awesome. So now the structure we have is we have one structure for frameworks. Again, you can play it differently on how you organize Argo, and you can play another one. We have another structure called cluster. Our framework is, our cluster is connected here. Now we're going to be doing is we're going to be connecting our application. We're going to be deploying an application, sorry. When we check the application, we're going to deploy a sample app. I'm doing it in two steps, but you can do it in one kind of single file. I'm just doing it so you can see how Shipa behaves on creating these. The first step is actually creating an app. And by creating an app, this is because Kubernetes needs it, but this is the part that matters. And you can see that it's easy for any developer to use. You're saying the application name, and you're saying what is the team that is going to be the owner in case your developer has multiple teams, project 1 or project 2, for example. And what's the framework that should be used to create and deploy this application. That's it on file 1. Or 0 in this case. In file 1, I'm going to be deploying the application where I say this is the app name that I want to run the deployment on. And this is the image I want to run the app. And here I'm going to be actually setting a policy of allow all. And you can see that this is super easy for any developer to use, as well as this, right? If your developer actually is the owner of the app and he wants to set customized policies for that app, he's setting allow all and deny all. And you can see the more detailed ones directly here as well on how to kind of define these policies. Well, let's see. I'll connect Argo to my first app. I'll do new app, and then I'll do K8 app 1, for example, project default, and I'll do manual, just so you folks can see. Same repo URL, but I'm grabbing the files from here. Sorry, here. I lost. There you go. Here's the path. I'm pointing to the same in cluster again. Argo has no clue what's the cluster address and so on. And then we create this app. You can see when we click on sync, we can see the different steps. Step 1, let's do it separately so you can see kind of Argo doing it with Shipa. Step 1 is just to create the app. When we click on create the app and we go into Shipa applications, we can see K8 app 1. It's created, but there's nothing deployed. I haven't deployed anything, but you can see already some application information, right? One of the things that we hear a lot is folks saying, who's the owner of the deployment or the application or the services post deployment. We see quite a few folks complaining about it later. At massive scale, it becomes hard to see who owns what. So here you can see the owner, the namespace where this is located, the plan in terms of resources that are being consumed, domain, environment, config maps, if you're loading any config map, for example, to the app and so on. And Shipa connects to an endpoint to your ingress controller and creates an endpoint for an application, both an external one and internal one. And if we go back to Argo and we say sync now, we'll do the network, the application deployment, sorry. If we do the deployment, and we go into the events part, you're going to see that the deployment is going to start in a second. And again, from a developer perspective, I don't need to know kind of go into Helm and maintain these things and so on. Yeah, I agree with Igor in that case, because if you have manifest and Helm and so on, it isn't easy to kind of go through and try to guess these infos. You see the deployment is running. It should finalize in a second. You can see that, okay, it's app 1. You can even see the log directly from here. It's already finalized. And for my app, I can see here, the developer, if it's up and running, they can see the application being accessed directly here through the endpoint. And as logs start coming or access to your application starts running, you're going to see transactions, resource utilization. If it's a multi-region cluster, you're going to see how your applications are being distributed. You can see life cycle of your application, so who created, who deployed, and so on. You're going to see security scans, integrations. You can do that directly from here or your developers into their incident management tools. So you can get, for example, Slack and say, every app deploy or someone who tries to shell into my app or set an environment variable, send an alert to this team and this channel on Slack. So it's easy for your developers to integrate into their existing workflows or PagerDuty and so on. They can set customized network policies directly from here, as well as other things. They can see how your application is actually built. So you can see here's the application code or image that I deployed, sorry. And here's the container unit. Here's the information on the deployment on the image, the pods, and so on. So if there is anything wrong, your developers can quickly map and see what happened wrong. If you have network policies, you can also define these network policies here. And so on and so forth. The last step, I think, which is already matching here, what we have is the network policy. Magic mouse, which is setting the network policy. If I see what I have, what did I have here as a network policy? Allow all and allow all. But if we go in and change, for example, from allow all, let me see what I have here from an app. On the app, we already have, sorry, my mouse seems to be going nuts. My app already has app allow all and allow all because of the default policy that was applied. If I come in here and I say deny all, deny all, deny all, I do git add, push, okay. And we go, so me as a developer or DevOps person, I change the app network policies, right? If I come in here and I do refresh, I'm gonna see that my network policy is out of sync. If I synchronize, it will call the Shipa API for that application. In the events, I'll be able to, in a second, to see that. And if we come into the app, the network policies now are changed to deny all and deny all. And this is also reflect on the network map. And we won't be able to access the application anymore. You can see that it's not accessible anymore. So it becomes extremely easy for your developers to now deploy their applications. In the same model, we won't have time because I want to be respectful for time, but in a follow-on session, I'll show you how to bind actually a Linux, which is something that the team is working on, binding a Linux cluster to the frameworks that you just created, and have the same application deployment model be used to deploy your applications on Linux nodes as well. So that can help you transition from your regular VM infrastructure later to Kubernetes using a single application operating model and without kind of changing the developer experience. So it is the same. So later on, if you want to adopt Kubernetes for a few apps, you can move a few apps, or if you want to use Terraform or others, the application operating model is still the same. And because Shipa and Argo are connected in this case, if someone goes in there by mistake and deletes the app, for example, you're going to see that in a second, as soon as Shipa notices the app has been deleted, Shipa will recreate the app, and then Shipa will start redeploying the app as well to bring it back to the state where it was before. I know we are running 2 minutes. We have a bunch of questions. Henrik, just wondering if you want to kind of triage some of the questions and maybe come back and we can try answering some.
Absolutely. We can start. There's a ton of questions here, but does it work with Lambda deployments at this point?
Pretty soon. So that's the application, the operating model that we're designing is the vision that we have is developers are going to use this, is going to be using this. They're going to be using the same operating model to deploy across multiple infrastructure. The next one that we're releasing is support to Linux VMs, again, EC2, VMware, and so on. So you're using the same thing across Kubernetes and Linux. And then we're going to be moving towards kind of serverless approach as well.
Okay. There's another question here related to deployment methods. What kind of methods can you achieve with Shipa, such as canary, A/B testing, etc.?
You can definitely do a couple of different options. I don't know if I have it here, but from a Shipa deployment perspective, let me see in the documentation. You can definitely do canary deployments as well as regular deployments and A/B tests, for example. So deploying your applications, here's one of the options that you have. For example, if you want to do in multiple steps, step wait interval, or if you have specific ports that you want to list for your applications, or if your application being pulled from a private registry. So there are multiple options that you can use directly from here, from a deployment perspective, as well as passing more information related to your app. We just use kind of a simple demo so we could get through it.
Okay, I guess there's a follow-up question from Peter related to the Lambda deployment about do we support ECS?
Not ECS yet. So the first target for us is releasing Shipa node support to Linux nodes, what we're calling Shipa nodes internally, same operating model. And in the self-hosted version of Shipa, actually, this is already available. We're actually moving this version to cloud. And then later Lambda, ECS most probably later, but it's not kind of right now. But it would be great to understand your requirements, Peter. Maybe we can connect later.
Then a separate question about do we support hybrid clusters models like Anthos, for instance?
Yeah. So the idea with Shipa is we're abstracting away the application operating model from the infrastructure, right? So you as a DevOps person, you can create the frameworks. And you can plug in a few frameworks to GKE, another framework to AKS, another to EKS, another one to Rancher, or to a VMware VM machine, and it's the same model. So we actually connect these frameworks and enforce the same policies across multiple clusters.
That's great. And then Igor is asking, in case if we're not using Crossplane, can we use plain Kubernetes manifests as an alternative, I guess?
Yeah, so Shipa does not take over your cluster in a way that we make it super easy for you DevOps to enforce the policies and controls and create that common operating model for the app and your developers across multiple infra. But if you want to go directly into your cluster and still use K8's manifests kind of that you want directly, nothing prevents you from that. And you can still use it. So Shipa is different than a solution like OpenShift, for example, that takes over the cluster and then that's what you're using and so on. Shipa is not doing that. Shipa creates the namespaces for the frameworks, and then the cluster is still entirely yours. You can install and use it in any way.
Cool. And then we've got some performance and quota related questions. So can I get the performance number for throughput for the network or the CPU numbers?
That's a pretty good question. So we have some transactional information such for your apps, status codes per second, request code per second. Right now there's nothing because there's no access to this app, response time and latency, for example, for your app, as well as resource such as CPU utilization, memory swap, and so on, open connections to it. And what we see folks using is later externalizing this to an external Prometheus, or even connecting their apps to Datadog so they can kind of sync the information, but they have some initial information here to help them troubleshoot the app.
And here's a good one actually in that regard. So how does the Shipa application quota relate to the limit set on the pod level for CPU and memory specifically?
So this is the maximum level of resources that your pods can actually use. So there are two things that you're setting, right? The maximum amount of resources that each pod can consume, CPU, memory, and swap, as well as you're saying how many units or how many containers an application can scale up to. So you can say, hey, these are the limits that I'm defining, and this is how many containers, for example, or units an application can scale up to, like 10. So you can now map exactly and know exactly how much resources you're going to be consuming, even if you're scaling.
Right. And here's a tricky one for you. What's the alternative to Shipa? Khalid is asking.
There's no alternative, my friend. I mean, I would say that the biggest alternative I would say that we see out there is folks trying to build their own things, and we often actually engage with companies that has been kind of 1 year or 2 years into that journey, trying to build their own thing. And it's complex, right? Especially if you want to build an operating model. What we see most teams building is around kind of one type of Kubernetes cluster, GKE, for example, and then using specifically Terraform or using Argo. And then later tomorrow, if they want to use Pulumi, for example, and Flux or whatever, then whatever they built is gone, and maintaining this thing, this is a product, right? So it's hard for an internal company to maintain. So this is by far, I would say, what we see the most out there. But after 1 or 2 years, we see a lot of folks kind of giving up on this because the complexity of maintaining is just not part of their core business. But that's what we see the most. Right.
And Bob is just asking a follow-up question, as in, do you see some overlap with Harness?
We actually released a video, and maybe Bob, we can send you that, is using Shipa with Harness, because when you're using Harness, you actually have to define the Helm charts and so on. Harness does not offer kind of a GitOps approach, kind of with resource sync, drift detection, and so on. So you can actually point Harness to a Shipa framework. So you don't need to be connecting your clusters to Harness and so on. And it becomes really powerful because then you use all the CI/CD capabilities from Harness, plus the policies, governance, and the application operating model from Shipa. So it's not a competitor in that case. If you want to see it as a competitor, you can, but we see it more as a value add. So you kind of do a complete stream across both tools.
Right. I think I have the last question here for this session here. How is the integration with Argo done? Do you read the CRDs? How's it done?
So that's a good question. So Shipa actually leverages. Yeah, Vivek, thank you for the link with Harness.
That's everybody.
Yeah, thank you. Oh yeah, that's right.
Yeah.
There you go. So Shipa actually creates a few controllers, a few CRDs, basically inside your cluster for app sync, network policy, and all the policies and app objects that Shipa is creating and monitoring. Those are CRDs actually that Argo, again, Argo is not calling your cluster directly, but rather Argo is calling the Shipa API in the framework. When Argo calls that framework, we actually connect to those CRDs and leverage them to create the objects, as well as manage those objects and detect any type of drift control and so on and so forth. But leveraging a bunch of different CRDs in your cluster and pointing Argo to the Shipa API instead. So you take developers out of your cluster. So you increase the security in that sense.
Okay, I'm sure I have forgotten a couple of questions in this. There's so many, but I think we're through most of them. you have any last minute questions, please ask them now. And if not, we're gonna wrap this up and send you folks a recording in an hour or two after it's been downloaded and processed.
Yeah, and we appreciate everyone who joined. We had a great attendance, and we had a great number of registrants as well. Again, the resources that we used are available on Shipa Cloud, so you can create an account on apps.shipa.io. Documentation is on apps.shipa.cloud. Sorry. Documentation is on learn.shipa.io, and you can also connect with us by Slack if you want. You can actually go to our Slack channel here, and you can chat with me, Henrik, Vivek, and everyone in the team directly there in our community channel as well. At the end of the day, what you're doing is you're creating kind of a central platform, right? You're doing a GitOps workflow across framework, policies, controls, and so on, and one application operating model that allows you to expand beyond Kubernetes. Audit becomes a lot easier. One application operating model, it's pluggable into your existing stack, so you can plug this easily into your PagerDuty, Slack, Teams, and so on and so forth. And it improves the developer performance because they are focused on that application model, no matter what infrastructure you use, and allows the DevOps folks to actually focus on the controls and choose. Again, if you want to move from GKE to AKS and from a Linux virtual machine, VM or VM to a Kubernetes cluster later, your developer won't even see that. You're actually changing those things on the back and not impacting the developer. Yeah, I think that's it. And
very good, Bruno. I think that's it.
Yeah, and we plan doing on that monthly. The next one may be around Terraform or Pulumi. Maybe it would be great to hear from you folks later on. We'll do a survey on what you wanted to see. We'll send you a few topics and go from there, or more things around Argo and Flux as well.
Very good.
Sounds
good.
Guys.
Appreciate it. Thank you
very much, folks. Bye.